The question we're trying to answer is to find the current through the 6 ohm resistor. Before we begin, it's important to know a couple facts about this circuit. First is, what is KCL? KCL is Kirchhoff's current law that states that currents entering a node equal the currents leaving a node. And this concept can help us solve a question on the current going through a certain resistor. By using KCL, we can use a method called node voltage method to solve this circuit. Node voltage method uses KCL to evaluate voltages and currents at certain nodes. This idea is useful if you're trying to find the current through a certain branch. The way we use this is to assign a ground node, which means a voltage equals 0. Then we want to assign names to the remaining nodes. Then we want to apply KCL for each node. Finally, we solve the equations simultaneously. However, in this problem, we have to utilize an extra step to solve using NVM. We're going to use a method called a supernode to connect two nodes that are apart by a voltage source. All we do is we simply combine equations by combining nodes with a voltage source between them. This can be seen right here with this example where there is a node V1 and a node V2, and they're separated by another voltage source, which I labeled VS. We can combine this and create a supernode. Here it shows that there's a current going out here, 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 and here, and we're able to make one combined equation using a supernode. The way we relate this V1 and V2 is by adding a constraint equation. This shows that from V1 to a voltage rise of Vs, that equals V2. To further explain a constraint equation, you can see that V1 with a voltage rise of Vs equals V2. In other words, we consider the change in voltage from V1 to V2 to be V1 plus Vs equals V2. All in all, to summarize, we write one equation around voltage source and relate the two nodes using a constraint equation. Now that we better understand KCL and node voltage method, it's pretty simple to solve this question. Start the question by declaring what our ground is. We say that right here the voltage equals 0, which we consider our ground. Next, we want to identify which ones are our nodes of choice. We name this as V1 for our first node, and here we name V2. Now, if you notice, the difference between this V1 and V2 is just a 6-volt voltage source, so we're able to create a constraint equation. We can say that V1 with a voltage drop of 6 volts equals V2, and this is denoted here as well. Now, we have to identify what we're solving for. The question says we want to find the current through the 6 ohm resistor. Therefore, by using Ohm's law, we can say that V2 over 6 ohms equals our amp of choice. Now we want to use node voltage method to solve for V2. We say that there are 4 currents entering and leaving the system, starting with the purple. We say, using Ohm's law, that V1 minus 12 volts to ground over 7.5 ohms is the first current leaving the node. Next, we say that there's a current source of 1 amps entering the node, so we denote this part of the equation as minus 1. It's important to note that we denote the current going out as positive and the current going in as negative, and that's just convention to simplify our question. Next, using the pink, we see a current leaving the system, and we say that V2 with the voltage drop of 16 to ground over 12 ohms is the third current. Finally, the current leaving here is V2 to ground over 6 ohms. Again, all these equations were derived using Ohm's law that V equals IR. The next step is to solve for V2 in order to find our equation of current at 6 ohms. To remove one variable from the system, I plugged in V1 in terms of V2 and was able to solve for V2. Here, to simplify the question further, I removed the fraction just to make the algebra simpler. Finally, I got to V2 of 8.17 volts, and I plugged that into the equation that I wanted to solve for in order to find a current of 1.36 amps as my final answer.